Aloha, Richard Halverson here. This is ITS128, and today is December 3rd. And let me share my screen. Okay. My screens are numbered differently today. All right. So anyway, so you're seeing the syllabus, I think. Let's see, let me widen this up a little bit. And let me click on here and open up the chat in case somebody wants to say something. All right, so we are we're doing class 28 today. We're December 3rd. We're learning about these things, these structures called classes. And it's just a way of kind of partitioning up your program in a way to make it so if you're working on a team and you're building a big project and everyone is assigned different sections of the code to write and to get working. Classes is a good way of doing it. And there's other reasons also why we use classes. But anyway, you don't need to use classes. And for a lot of the code that we've been writing so far, we've kind of been using classes in a subtle way, but the stuff that we have been writing has generally not been classes. It's just been code that just executes. But classes lets you modularize your code and enforce certain rules to protect things from getting messed up when your projects scale up. So anyway, we're in the second half of chapter 9, and last time we covered up to chapter 9.5 here, and we did a couple of these down here. 9.5 was the last section where we talked about defining these classes. In this example here, you have a class called a seat, and this is like a seat on an airplane. And seats are assigned to people. So the main thing about a seat is that there's a first name and a last name and the amount that the person paid for it. And then there's other methods you can do on the seat. You can assign it the names, you can reserve it. In other words, you put values to first name, last name, and paid. You can make empty, which clears them out. But when a seat is created, it's just created as a seat. There's no default value. There's default values, but you can't change those default values. And so, but you could still, do limited operations on the little data variables that are inside of a particular seat. Okay, so anyway, so class constructors, this is section 9.6 now, is where we introduce this idea where you can create things, but when you create the instance of that class, or when you create the object that's of that class type, you can assign values right away. And so in other words, you have parameters. Okay, so here's and so we're talking about class constructors. A constructor is a thing that sets everything up when you create a new object. It sets everything up in memory. And so now we're going to talk about all the ways constructors can be different. One is passing in some parameters. And so here we have a class called race time, and it is and you, I guess, would create an object, a race time object for every racer, and that race time, that object that you create that goes along, that's associated with that racer, has got a start time and an end time and a distance traveled or distance ran, I guess. How far they ran and the start time and the end time that it took them to run that distance. And so here, so when you create a new object, you automatically assign these values, and these values are different for each racer. So here's how you might use it. You're creating you know, an instance of a race time for Jason, and start time, end time, and how far he ran, and so on. So so that is this here is the constructor, and so constructors can take on parameters basically, and so that's pretty cool. So write the definition of a init method, a constructor that requires the parameters. So requires these two parameters when you construct it. So it'd look like something like a def init, and then you always have to have that self thing, and then X and Y, those are required. Something like that. All right. You can also have default parameters for these constructors. So that means that they're not required anymore. If you leave them out, it takes the default. And so here you can create a person create an object. It's an employee object. The employee object has a name property or name attribute, and it's got a wage and it's got an hours. And when you're creating a new employee object, if you don't specify the hours, it just defaults it to 20. And if you don't specify the wage, it defaults to $8.25. And so this is what the constructor looks like. The constructor looks the same as it would if these parameters were required, as they are up here. Here they're required. See, and this is what you do with them. Now, this name does not have to be the same as this. This name does not have to be the same as this name, but it's convenient to do so. It makes it easier to remember. Okay, but just keep in mind that this one is this one. Okay, this is the parameter start minutes, and this is the actual variable that's allocated inside of the object when the object is allocated. Okay, so that's the memory location. All right, so that's constructors with default parameters. So here we're testing our cleverness on how we can figure this out. Okay, so what we're supposed to do is we have this class thing here, and there's some different ways of using it, of creating an instance of a student. And this one, for example, the instance is the name is Johnny, the grade is 11, and honors is true. Now you notice the default is name has to be specified, but the default grade is 9, and the default honors is false, and the default athletics is false. So the fact that we are actually specifying 11 and true here, but the athletics remains false. So let's figure out which one it is. It's Johnny. It's going to be one of the last two, because one of the last two is Johnny. Grade 11. They're both grade 11. Okay, here honors is false, and that's the default. So these two are default, but this is the one that was actually not the default, and so it's specified. So this one goes down here. And then this is dumb, because we already know what the other Johnny is, this one. And Tommy is all default. So grade 9 false, false. Tommy is grade 9 false, false. Okay, so that's the first one here. Okay, so anyway, here's a challenge activity. Constructor customization, customizing the constructor. Okay, so here we have a rectangle, and we created a rectangle object, length 2 width 11. Okay, so here we're writing the length of the first one and writing the length of the second one, and that would be the 2 and the 5. So that's what's written there. Okay, let's do the next one. We're writing the length and we're writing the length. And the length is the first one, and the length is the first one. And this rectangle 1, rectangle, okay, so same order, so it's just 3, 6, enter. Okay, so anyway, these are pretty easy. Here we have, we're writing 3, then we're writing 2, and then we're writing 1. Well, what's 3? 3 is rectangle 8. So that must mean the length is 8. Oh, we're writing the width of 3. So the width of 3 is going to be 6 because it's not specified. So it's going to take the default. So 6 is going to be printed first. And next, rectangle 2, which is a default rectangle, and we're printing the length, and that length is 7. So this one must be 7. And then we're printing rectangle 1, and it's the length of rectangle 1, and that's this one. And the length of the rectangle 1 looks like it's a 4. Very good. All right. Okay, challenge activity. Write a constructor with parameters self and then number of minutes and number of messages. Number of minutes and number of messages should have a default value of 0. And so okay, so these are plans. What kind of plans? They're phone plans. And the phone plan can have, it's got number of minutes and number of messages. So that's 2, okay, those 2 parameters. So init would be init, def init self comma num mins num messages. But there's default, and the default is 0, and the number of messages default is 0. And then what else? We got to set these values equal to something. So you got to set self.num mins equals num mins, and self num messages equals num messages. Okay, so that just takes that parameter, stores it in that slot there, and takes this one, stores it in that slot there. That's all that does. I don't know. So anyway, that should get you going on that one. What's next? Class interfaces. All right. So this is just this just talks about how you interface to a class, and you interface to a class, I guess, by the parameters. When you create an object from it, but also when you invoke some of the methods that go along with it, like invoking the print time for an object. When you create an object and you want to you want to take advantage of that method that goes along with that object to print out the time or to print out the pace. So these are the interfaces of a class. And so prepend and underscore. Oh yes, okay. So what they're talking about, this a good practice to prepend and underscore to methods that are used internally by a class. Okay, so here in this class we got the constructor, and there's no default values. So if you're gonna create an object from this class, you better specify every one of these things, otherwise it's not going to be valid. Here we are this print time is accessible by the, it's like we have an object here. You want to print the time. There's a method for that. You have a new object here. You want to print the pace. There's a method for that. Now this method here, this method is accessible by the outside world, but it's not intended to be. So the convention is you put an underscore there, and an underscore is just like a letter, and for a variable name, or a method name, or anything. An underscore is just like a letter, but it's not common to start names with underscores. So that's the convention, and the idea here is that this class has methods, and these methods, that the methods that are part of the interface, but these methods have other methods that they use internally, and this is one of those internal methods. It calculates the difference between two time values. So you have an end time and a start time. You have a start time and you have an end time, and you want to calculate the difference between the start time and the end time. Well, it's not that easy, because there's minutes and there's hours, and sometimes the minutes of the end time might be a lower number than the minutes of the start time. So then you gotta then it gets complicated, right? If so there has to be a method for that, and that particular operation is used in more than one place. So then it makes sense to make a method, a function that's only used internally. Okay, so that's what that is. So these are classes that get more. They kind of get more complex, but that's all that to help you be able to split the work up on a big project, and everybody goes off and debugs their own code, and then they come back, and then if everyone's classes work, and they're tested and they work, and they work according to their specification, then when you all come back and put them all together to see the whole system run, if it doesn't run, then it's just in somehow how you defined interconnecting those modules, but it's not any one of the classes, assuming that you define the classes correctly. So anyway, now here, just as an example, here we're just we are reading in a start time, reading an end time, and then we're printing out the time and we're printing out the pace. Now, if that's all we wanted, we could just write a program to do that, and we wouldn't need any of this class stuff. Okay, this is a class, and it takes as arguments the hours, minutes, and of the start and beginning, at the end, and the distance, and it returns this object, this race time it returns this pair. It returns an hours, minutes pair, and you're able to here you're able to print. After you define this thing, you print the time by activating this method that comes along with the class, because you used it, and the pace, and so on. So you have to also appreciate that many times when you're just coding something because you want to find out the answer quickly, and the easiest thing to do is to write a little program to do it. You don't have to use all this class stuff, but we're going to be using it more and more because pretty quickly you do start using classes, and you start to use your own classes. And so we're going to learn ways of defining classes, testing classes, and then you just leave it alone, and then you just need to import that file that's got that class in there that you defined. You just import that into another program of yours, and then you can use it by using the dot operator. All right, these are called abstract data types. So here it talks about, make sure you understand the concepts of an interface. The class interface consists of the methods that a programmer should use to modify or access a class. I guess so. Internal methods used by the class should start with an underscore in their name. Yeah, they don't have to, but sure, that's a nice convention. Internal methods cannot be called. Well, they can be called. They can be called. See, that's the whole thing. It's just a convention. Now, in other programming languages, you define them as internal. In Visual, in C#, when you define methods, you define them as internal or private, or public or private are the terms. So anyway, class customization. Okay, so there are ways of customizing classes, and really what you're doing, well, you're customizing classes, but you're customizing how the operators work, on the classes, or how the operators work when using the classes. And by operators, I mean like less than or equal or greater than or greater than or equal, or print, or that kind of stuff. So there's these special method names that the Python interpreter recognizes, and really what you're doing is you're overriding the functionality of an operator or an operation. Okay, the first one is if you define a method inside your class that's named __str___, then you are redefining what happens when you want to print the class, or when you want to print an object that's defined by the class, an object of the class. Okay, so this is just normal. This is when you haven't done anything like that, and you define a class, and then you create an instance, you create an object based on that class, and then you decide you want to print out what that, you want to print out that object. Well, when you do that, all it does is it prints out the name, and then and then the physical RAM memory address of the object in that page, or and that's relative domain, I presume, or something. So anyway, this is a hex address. This is a memory address. So let's redefine what happens when you use the print method on the print function on an object. And the way to do that is you define this, and it's __str__, and this is what you return when and you just have like a print thing there. And so now when you do this, it's going to print out, monster truck XXX costs $14.99, not for children under 5, or some crazy thing like that. So you can do that. You can also so you can go through this here. You're just here you're actually writing that method. So you're going to write something that looks like this or something. So you can start by taking this and copying it here, or maybe it actually tells you what it is down here. I guess not. All right, so that's just what we're still talking about str. Okay, so it's called operator overloading, and here you're messing with these operators. Now these are these two, for example, are operators that they take two operands. It's an infix. It's called an infix operator because it's an operator that's in the middle of two operands, and it's going to return a true or false. So this operation returns a true or false. But what does less than mean when you're talking about two objects? It's a certain operation where where object A is going to be less than, it's either true or false that object A is less than object B, but what does less than mean? Well, as long as you can express it in a in code, then you can, you know, define it. So here, for example, when we're talking about time, you know, time is, you have an hours field and a minutes field, and so we know that this time 10:40 is less than 12:15. Okay, even though 40 is more than 15, it doesn't matter because 12 is more than 10. Okay, so we can, you know, express the, you know, the operation, which will give us a true or false answer, whether this is less than this. And that is, first you say, you check to see if your hours, you know, the left side, the left operand hours is less than the right operand hours. If the less operand hours, that's this 12. If 10 is less than 12, then you're already done. It doesn't matter what the minutes field is. So you can just return true. Otherwise, if the hours are equal, then you got to look at the minutes. So there you look, if the minutes, if the left operand's minutes is less than the right operand's minutes, then you know that it's that the left one is less than the right one, so you return true. Any other case, you would return false. And the any other case is if self hours is greater than other hours. In other words, it's or they can be equal, but the minutes is greater than the. Actually, it's greater than or equal to, because because it's a less than operator and not less than or equal to operator. All right, so that's how you can redefine these kinds of operators, and you can do the same thing with plus and minus. You know, adding, there's a left operand and a right operand, and there's a plus sign, and the result is something. And the asterisk operator too, which when we're talking two integers, you know, these are if we're talking two integers, then the asterisk operator multiplies. Okay, if we're talking about a string on the left and an asterisk on the and an integer on the right, then it's a string operation which will repeat that string, you know, that the integer number of times. And so there's already built-in overloading of these operators that Python, you know, already gives you, but this allows you to go ahead and define them for different kinds of classes or different kinds of objects that you might want to create when you're writing your programs. And so these are methods like, you know, this less than operator are also known as rich comparison methods, just what they're called. If you hear that, oh, the rich comparison methods, oh, that's the overloading of the you know, less than, greater than, and I would say the multiplication division kind of operators, where you have two operands, a left and a right. All right, so so here we are talking about quarterbacks, I guess. So this is a sports example. You have a less than and a greater than operators that you're defining. So, you know, you define them in some way. I guess you define them by a rating is, you know, first you, okay, so a quarterback, you know, you create an instance of a quarterback and with certain parameters, and those are the number of yards, attempts, completions, touchdowns, interceptions, which is a negative thing, and then wins. And they got some formula here, some crazy formula that whatever, but it's a formula. And so that gives each object, each quarterback object, a particular rating value. And so when we are testing if one quarterback is less than another quarterback, when we're testing, we either if the quarterback on the we're testing if the quarterback on the left is less than the quarterback on the right. Okay, so if the rating of the quarterback on the left is less than the rating of the quarterback on the right, or if the quarterback on the left has less wins, fewer wins, I guess, than the quarterback on the right. If either of those is true, then it's true that the quarterback on the left is less than the quarterback on the right. Now, wait a second. This is not very good, because it's possible for quarterback A to be less than quarterback B, and for quarterback B to be less than quarterback A. And that's not transitive or some properties. See what I'm saying? What if the rating, Joe's rating is less. Joe has a lower rating but higher wins than Fred. Joe has a lower rating but more wins than Fred. Well, then they're both less than each other, right? I mean, I got to think about that one more. All right, so anyway, so here we're supposed to write if car is less than this car. So what is it? If a car is less than another car if the price is lower. Oh, okay. So if self price is less than other price. Yeah, okay. Right. All right, so enter the output of a program that has a class with several methods. Okay, so we've got all right, so this one, you define a class, you create an object of duration, and the 5 hours and 0 minutes. And when you print it out, it's going to print out, first of all, it's going to take its minutes attribute. If it's less than 10, it's going to print this. No, it's going to say that. Oh. This is the first minute string. Is this? Oh, it's just this 0, 0. Oh, I get it. If the number of minutes is less than 10, then you want to stick a 0 in front of it. So it looks like that. And that's all this is. This says you want it to look like this, and replace this with this. And you only do that when this is less than 10. Oh, that's the string. I got it. Okay. Okay. Or yeah. This is a number, and this is a number. This is a string, and the reason you got to do this is because because this is a string value that you want to go here. It's not a number. It's a string inside of a string. So anyway, okay, so that's why that looks like that. Ooh, this is kind of complicated, isn't it? So let's start. Let's do the next one. Right, there's two of them. All right, let's see what happens. So if it's less than 10, then you want to print the 0, and we'll print duration of 2. So hours is 2, and minutes is 0. So self hours is first. That would be here. So hours is 2, comma, and then whatever minute string is, and minute string is going to be, you know, zeros. It's the 0, 0, because minutes is less than 10. So this is going to happen, and all that does is append a 0, or it sticks a 0 in front of whatever the minute value is that's less than 10. So anyway, let's see if that's right. Oh, do I got to do this? And it's a comma, right? Okay. Yeah, it's a comma. All right, well, anyway, you can do more of those. Write a special method for this for car record. Okay, so when this thing runs, 2009 goes into this. The year is 2009, and the VIN number is that, I guess. And you want the str function, or when you say print my car, you want it to print out this. So you want it to print def str. Do I got to do the self thing? Yes, I do. Self. And I want to do print year. Year, colon, close that, and then I'll print out the year, which is str my car year made. Oh, I need a comma, so, and I need to have it be right next to, I need to have it be right next to the year made, so I'm just gonna have to append it. A comma, this is kind of a sloppy way of doing it, but then I can do a comma, and I can do, oh no, I can just space VIN colon, I can just close that there, put a comma, and type my car dot car VIN. No, I don't, it's not print, it's return, right? Yeah, it's return. return plus. I really should be using this formatting way of doing it, but I'm lazy. I'm going to do it this way. All right, that should this should be plus space plus. I wonder if that works. Oh, it worked. Oh, oh. Hmm. What did I do wrong? Let's see. Now I gotta fix something. Car record. Year made. Oh, stupid. It should be self. Yeah, okay. Yeah, that's better. All right. Ooh, yeah, okay. I can see why that happened. Okay, so, all right, what's next? Okay, overload. Okay, so, Aaron asked me to explain abstract data types more. Let's see, that was back here. Get interfaces. Here. Okay, a class can be right. A class can be used to implement a computing concept known as an abstract data type, and it's a data. Okay, it's a type of data. You know, like an integer is a type of data, a string is a type of data, and these other things that we've been looking at can be think of as types of data. You can create instances of them. You can create an instance of an integer. You can create an instance of a string, and you can create an instance of these other things. And when we say abstract, we're more or less implying that there's things about it that are hidden. The actual implementation of things are hidden. Okay, and so this concept of information hiding, and what's hidden is both, you know, certain variables that it has to keep track of that, you know, in doing its thing. It's not necessarily variables or any kind of information that would need to be accessible by the outside world, but to keep its internal, to keep track of everything that it has to do internally to be able to provide, you know, the functionality that it does. It has variables, and just like these methods, like this method here that starts with an underscore, it's not the intention that this ever be used outside. So this is like an abstraction of something that's needed, and later on you can find some more efficient way of perhaps doing this method here, and you can just change it, and it doesn't you know, really affect anything. You can change the way these are implemented. It's not the same as encryption. Encryption, you're intentionally trying to hide information that the outside world may want. Okay, so It's like let's say it's you have a class that requires a secret password to be able to access certain methods. You may want to hide the actual password, and so you hide the password in a way where you can test the person. You can test if the password is correct, but you cannot look at it. You can't look inside the code at all to be able to decipher what the password is. You can test if it's correct by doing an operation on it, and it says yes or no, but you can't look at the operation that tests it to be able to figure out what password would work on that. So that's not the same thing. Abstraction is more out of convenience. It's there's this abstract data type or this class that presumably, since it's a class, you're going to want to make more than one of them, and you're going to probably want to use it for a long period of time, perhaps. And there's different ways of, and this abstract data type provides some sort of functionality. Okay, one of them is his sorting. Let's say you have a list. You have an abstract data type, and it's a list, and you have a method that where you do the method, and it sorts it. You know, once you do the method, it's sorted. Well, you know that there's like 3 or 4 or 5 main ways of sorting that you would choose depending on the nature of the data. If it's really sparse, you would choose one kind of sorting method. If it's almost sorted but not quite sorted, you would choose a different kind of sorting method. Where if it's like completely unsorted, completely random, you wouldn't choose the same sorting method that you would if it were you know, partially sorted already. So you're you leave it up to the class or the internal workings of the data type, you know, to decide. Okay, so it's a bunch of stuff that the user of the class doesn't have to know about, and it's easy when you're dealing with these abstract data types. These classes are designed to be able to define them, where it's easy for the user who's going to use them to see the methods that they're going to use. These are the features of the class, and then there's a bunch of stuff that should remain hidden because there's no reason. So it is a simplification. It's a simplification of not only the data but of the functions that you used, that you are going to let the functions that you're going to want to do on the data. And you only need to tell the user enough to know how to do it, and you don't have to tell the user how you're doing it. And so that how you do it is abstracted away. And there's also things where if you want a really small compact implementation, if you don't have very much room for your program, so you use much more simplistic algorithms that may take a lot longer to run, but it doesn't matter because you're dealing with something that computers can run pretty fast, and so it may run certainly fast enough for what for what it's interfacing to. But so you implement it using real simple functions, low code functions, don't require a lot of code, that don't require a lot of program memory, but they're slow. And that's one version, and then you have another version that's a super high-speed version in the class. It looks exactly the same, it operates exactly the same method names, same parameters, same defaults, but it runs way faster, and that's an example of stuff that you would want to abstract away. So anyway, fancy term, and all it means is that you can build these fancy types of data that represent all kinds of stuff, that represents a race time, and you think of it as an object. And so how many race time objects do we have? Well, obviously we have as many race time objects as we have racers, and so and you know there's you know and also we'll learn that you can take a class and then you can create a new class on top of it. You can add to that class by adding methods. So you have a class, a base class, and then you want to you know add some attributes to it. You know that's also something that you can do with classes. All right, so let's keep moving here. Class customization. Yeah, that's what we're talking about. We already did that section. More operator overloading. Subtraction. This is doing subtractions and stuff. That's for those kinds of operators. So this is instance is you're able to test if a certain object is a particular type of class or not. So you know you can test if you know, let's say you know you have a time. Say you have a time and it's an object, and then you want to subtract something from it, and you may want to do it where you may want to look at what the other is, and if the other is another time object, then you'll go do that fancy, you know, different subtraction thing that you do between two time objects, and you look at the hours and look at the minutes and so on. But let's say that the other is not a time object at all, it's just an integer. Well, then, you know, you have a definition for that, and that is that it's going to be hours. So you can, if you're just going to subtract a plain old integer from a time object, what you're subtracting is hours. And so, you know, it's able to do that operation. So that's when you would use the isInstance method. So you test if some object is of a particular type. So anyway, that's pretty cool. And so, you know, you can override all these kinds of, or make definitions for all these kinds of things. All the infix, they're called infix operators because they're in between the two operands are, it's you know, it's not, you know, like this is a you know, prefix notation where you have the function name and then the two operands, okay? The function name and the two operands. And so, but these are all how to redefine the infix operators. The infix operators, you have a symbol in the middle, and then there's a left operand and a right operand. You know, instead of, there's still two operands, there's still something that says what it is, but for an infix operator, it's some kind of symbol, and the operands are to the left and the right, but it's still going to result in either a number or true or false or something. You know, that's like all these, they still result in a number or a true or false or something, or they result in something. Same with these, but so basically Python lets you redefine all the infix operators. You know, not every language is like that. Operator overloading. All right, so anyway, you can look at that and see, what is this? Enter, what time is it? 4:10. You know, but to be honest with you, you don't do this very often. Okay, this is memory allocation and garbage collection. You don't really have to know about this, but basically, you know, the way Python allocates memory and the way it changes the address of something, the pointer, you say something is equal to something, and really you have a name, now it's pointing to something else. It's possible that stuff gets left out there hanging and there's nothing pointing to it, okay? It's not perfect. And, you know, they try to make sure that that doesn't happen, but, you know, they're designing all this stuff, and, you know, the programmer's doing all kinds of stuff, and it's possible that stuff gets left out there, this memory is being taken up, and there's no way to get at it because there's no variable that's pointing to it anymore. And And every now and then that happens, and every now and then you got to do this garbage collection thing where it says hold everything, and it goes through and it follows all the links, and it finds all the memory that's not that you can't get to anymore, and it swoops all that up and reallocates everything and puts that memory, that garbage that it found, puts it back in the memory pool so it can be used again. And there's actually programs that, you know, someone's got to write those programs. Those are operating systems programs. But anyway, that's what they talk about here, and why you would do it and how it happens and how it works and everything. Yeah, so this is not important for you to really know, not at this stage in your programming career, but it's nice to know about it, because someday if you like this, you might go off and you might actually be writing, you know, programs that do that someday. All right, so so we're doing the labs now, and we did this one last time, and this is where we are just defining the constructor, no constructor, and we're finishing defining the constructor, and we're finishing defining this method that can be used when you create an object of this class type. This method. So it's just a simple class with no parameters or anything, and we did that last time. We also did this one last time, this nutritional information. Here we hadn't talked. Let's see, here it's a class, and methods, define a constructor with parameters. Okay, so in this one, which we did last time, we did have to define a class, the constructor, with these additional parameters coming in, and we did that. So when you create a new food item object, you have to pass it a name, an amount of fat, an amount of carbs, and an amount of protein. And I think what we did is we just, this was an easy one. We just had to fill in what this is down here, you know, self name equals name kind of thing, and so on. Fill those in, and then here we just have to put the, is this something, all right? No, this is already there. Is that all we got to do? Is that all we got? I guess that's all we got to do. We have to finish defining the, finish defining the constructor here. All right, so that was pretty easy. I can leave it. All right, it's 4:15. Artwork label, class constructors. This is artwork label. Okay, so all right. So we have this an artist class and an artwork class, and in this one, the artwork class takes as a parameter an artist object. So we have this artwork class. The artwork class here takes a title, a year, and an artist. This user artist is an object of this type, and this is a class which is defined first. Okay, so first of all, we have to define the constructor with parameters to initialize instance attributes. Initialize instance attributes, so it's going to be something like def underscore init underscore self comma name, birth year, death year, but there's defaults. The defaults are none, 0, 0. Oh, and print should be this. Okay. So this is going to be name is none equals none. Birth year equals 0. And death year equals 0. So those are the defaults. Oh, and then we got to do all this self.name equals name, self.birth year equals birth year, self.death year. I think that's it. And then the print thing, we got to do this print thing. And, oh, we got to do a lot here. Okay, so artwork is going to do the same kind of thing. Def, self, and then you got to figure out what the all right, so when you're printing, you're going to print artist name, let's just see what it is. Artist name like that, or artist name like that. Okay, so def, is it string? Is this an str thing? I think it is. No, it's not. It's not. It's a print info thing. It's just a method. See, it's just a method. What we want it to print is we want to if self death year equals -1, then the guy's still alive. The guy's still kicking. Print, and I'm going to do this this squiggly curly thing. Artist colon squiggly born squiggly that with I want to put in there self name and self birth year. So that's what I want to put in there. So it's going to print artist name, born 19 whatever. Otherwise, it's going to do else something that looks kind of like this. Oops. Except for it's going to be more like from there, that person lived from that year to that year. Self death year. So that'll be for the that looks like that's for that. And let me just do this one here for you. This init thing. To default it, does it say what the default is? Initialize the title to none, the year created to 0, and the artist use the default artist default constructor parameter. So just say, okay, so it's just equals. That'll do the default. And this is going to be title is none. What's the year created? 0. All right, so that's gonna, and then you got to do all the, you know, self dot title equals title, you know, self dot year created equals year created, and so on. You know. So, and then you got to do the print similar to this, except for you're going to do it's just going to do it's just going to print out this. So anyway, so you can do that. Anyway, so that's this one. Looks pretty good. Let's see what's next. I can leave. All right, triangle classes. Given a class triangle, complete the program to read and set the base and height. Determine the area and output the larger one. Okay, so we're gonna okay, so we have a triangle class here. Nothing fancy. No defaults. We have a set base method. We have a set height method. We have a method that will return the calculated area, and we have a print info. And so we have so we're going to read in triangle 1, and then we're going to read in triangle 2, and then we're going to print out which triangle has a larger area. Okay, triangle. Okay, so read in triangle 1. It's going to be something like okay, I created a new triangle. Now I'm going to read that in. I'm going to just read in triangle 1 dot set base. I'm just setting the base. I'm just setting the base and height. Those are the only two things I read in. Those are the only two things you got to find out. So I'm going to do it this way. I'm going to really do it compact code here. I'm going to do float input. See? So this is going to read in an input, convert it to floating point, and it's going to pop that number, that floating point number, right into the base of triangle 1. And another one, triangle 1, set, what's the second thing I got to set? Height. Set height, float, input. Okay, so that pops that in there. And same with this, except for we're doing 2. Determine which one is bigger. All right. If triangle 1 dot get area is bigger than triangle 2 get area. If triangle 1 is bigger, then print I guess we just print triangle 1 get info, print info. Okay, well, else. So it should actually be triangles are the same size. You know, this is actually not the right answer. I mean, you actually don't do this one. This is supposed to go here, I guess. Whatever. Actually, you know, this is fancier. I guess you're supposed to assume that one is going to be bigger than the other. But anyway, let's see what this does. Actually, I want to see what this does. It's going to say it's not right. Oh, what did it do? I forgot something. This is set height. Line 27 doesn't like. What it doesn't like. Set base, set height. Oh, maybe I need to put data here. That's what it is. Copy. Paste. No, it can't be right. Syntax error. What's what it doesn't like about this? Capital word? No, this should be capital, but these are not capital. I'm going to copy this, and I'm going to go over here. Save. Open this up. CD desktop. Python test.py. Invalid syntax. All right, well, the actual user base equals float input and user excuse me, height equals float input, and this is user base, and this is user height. Does this work? No. That's weird. Okay, well, it's same thing here, I guess. Huh? I wonder why that didn't work. 3.0, 4.0, 4.0, 5.0. Triangle. Where was that? Triangle 1. Triangle 2. Oh, this one. This should be also triangle 2. Three point oh, 4.0, 4.0, 5.0. The large area 4, 5, 10. Sure, right. 4, yeah. Okay. Well, anyway, that's weird. I can't. So this doesn't work. That's amazing. No. Okay. Anyway, it should be this. And this should just be. I wonder if that would. I wonder if this would work. Oh, it did work. Wow, it sure tested a lot of them. Okay, so the last one here is 9.15, winning team. Let's see. So in this one, we're supposed to create there's a class called team, and you're going to enter. You're going to set the names, the name and the wins and the losses, and you're going to read those in. You're going to set this object called team. You're going to set that equal to you're going to set these attributes. You're going to set these attributes of this team object to those values you just read in. And if the percentage, the win percentage, which is a function, a method that you get along when you create an object of this type. If it's greater than a half, then you say it's a winning average. Otherwise, you say it's a losing average. Okay, so what we just need to do is finish. The prints are all there. We just need to define this, get winning average. So the class, it's get winning percentage, which is this. This is the formula for winning percentages. I'm just going to copy that. Use floating point notation. So right here would be something like def get win percentage. Any arguments? No, there's not. Team wins. This is self team wins. Self. This is, I think we're just going to return this, huh? Return this value. Return. And we got to put self in front of this thing. Self, self, and self. I think that's all you got to do. Ravens 13.3. Develop mode, run program. Congratulations. Ravens has a winning average. How about if I make it 313? Ravens has a losing average. All right. Well, anyway, I think that might be all you need to do. You can submit it, see if you get all the points. Anyway, so that's it for this chapter. We've gone all the way up to 9:15, and next week we can start on chapter 12. Thanks for watching.